Distance formula from a point to a plane. Consider a plane P with a given equation and a point A not included in P. So the distance from A to P is always given by this formula. For example, in this case, where the equation of P and the coordinates of A are given, by applying the formula, we get that the distance AP is equal to 4 over radical 21. Distance from a point to a line. Consider a line D with a given equation and a point A non-belonging to D. So the distance from A to D is always given by this formula, where VD is the direction vector to D and B is any fixed point on D. For example, in this case, having the equation of D, we can conclude the direction vector and a fixed point B. Then, by applying the formula, we get the distance from A to D. Angle between two vectors. Given two vectors u and v, their angle can be found in two ways. Either by its cosine, which is based on the scalar product formula, or by its sine, which is based on the cross product formula. We will take some examples later, but it's important to know that all kinds of angles that we will explain in this lesson will refer to angles between two vectors. Angle between two lines. Given two non-parallel lines D and D', if V and V' are respectively two direction vectors to D and D', then the angle between D and D' will be equal to the one between V and V'. So it refers to an angle between two vectors. Angle between two planes. Given two intersecting planes P and P', if n and n' are respectively two normal vectors to P and P', the angle between P and P' will be equal to the one between n and n'. So it refers to an angle between two vectors also. Angle between a line and a plane. Given a line D and a plane P, if n is a normal vector to P and V is a direction vector to D, then the angle between D and D' will be equal to 90 degrees minus the angle between n and V. So it refers to an angle between two vectors also. Examples. Given the equations of two lines D and D' and the plane P, first, to find the angle between D and D', which is equal to the angle alpha between V and V', let's calculate cosine alpha based on the scalar product formula. Here is the result. Secondly, to find the angle between the line D and the plane P, which is equal to 90 degrees minus the angle alpha between n and V, let's calculate cosine alpha based on the scalar product formula. Here is the result.